Good day, everyone. So today I'm going to discuss what is constitutional isomers. So in this presentation, we will learn what is constitutional isomers and why are they formed, and also how to identify them using a simple example. So before we start, these are our learning objectives. At the end of this presentation, we should be able to define constitutional isomers, explain why they are formed, identify them using simple example, and understand why they are important in organic chemistry. What are constitutional isomers? Constitutional isomers are compounds that have the same molecular formula but different connections of atoms. So in simple words, pareho sila og number sa atoms pero lahi ang ilahang pagka-connect o pagka-arrange sa ilahang atoms. So because of this, they are become different compounds. Next is the difference between molecular formula and structural formula. So, ang molecular formula only tells us the number of atoms in a compound. For example, 3 carbon, 8 hydrogen, and oxygen means the compound has the 3 carbon atoms, 8 hydrogen atoms, and 1 oxygen atom. On the other hand, ang structural formula shows how these atoms are connected. So, two compounds can have the same molecular formula but different structural formulas. Why do constitutional isomers occur? Constitutional isomers occur because carbon atoms can bond in different positions. When the arrangement of atoms changes, a different compounds is formed. Mao nga bisan pareho sila og molecular formula, mahimong lahi pod ang ilahang structure. Example 1, 1-propanol. So, here's our first example, 1-propanol. It has the molecular formula, carbon 3, hydrogen 8, and oxygen. So, in this compound, the OH group or alcohol group is attached to the first carbon atoms. That's why matawag siya nga 1-propanol. Example 2, 2-propanol. So, this example 2, the 2-propanol, it has also the molecular formula na carbon 3, hydrogen 8, and oxygen. But, this time, ang OH group is attached na siya sa second carbon atom. So, although both compounds have the same molecular formula, the position of OH group is different. So, it is making them constitutional isomers. Next is comparing the two isomers. So, both have the same molecular formula, which is the carbon 3, hydrogen 8, and the oxygen. So, the difference is that 1-propanol has the OH group on a 1 carbon, while ang 2-propanol kay naa siya'y na-attach siya sa OH group sa ikaduha siya nga carbon. So, because their atoms are connected differently, they are called constitutional isomers. So, next slide is the longest carbon chain. So, when naming an organic compounds, the first step is to find the longest continuous carbon chain. So, this longest chain becomes the parent name of the compound. For example, if there are 3 carbon atoms in the longest chain, the parent name is called propane. So, next is simple IUPAC naming. So, these are the basic steps in IUPAC naming. First is to find the longest carbon chain. Second is to number the carbon atoms. Third is identify the functional group or branch. Then finally, write the correct IUPAC name. So, following these steps help us to name the compounds correctly. So next slide is the physical and chemical properties. So even if constitutional isomers have the same molecular formula, they can have different properties. So they may have different boiling points, melting points, odor, solubility, and chemical reactions. So this happens because their structure are different. Importance of constitutional isomers. So, constitutional isomers are important because they help us identify and name compounds correctly. So, they are also useful in understanding organic reaction and making medicines, fuels, and chemicals. So, in agriculture, they help scientists study pesticides and herbicides. So, summary. To summarize, constitutional isomers are compounds with the same molecular formula but different atom connections. So, they are formed because carbon atoms can bond in different ways. Since their structure are different, they may also have different properties. And understanding constitutional isomers help us to identify, name, and study organic compound more accurately. So, that's the end of my presentation about the constitutional isomers. So, thank you everyone for listening. And if you have any questions, you can comment below.